Today, I'm going to explain briefly what is important to remember during exam time. So, first, generated EMF in DC generator. So, generated EMF in DC generator is denoted as EG, that is equal to Z5PN by 60A. You remember this formula, where Z is equal to total number of conductor in armature, and phi is equal to flux per pole, and unit is in Weber. N is equal to speed of rotation in RPM, that is revolution per minute. P is equal to number of pole. So how to draw? Different type of DC generator. You draw a circle, then as generator, so inside it there will be generated EMF EG, and current should go out from the armature. This is the armature. This is A terminal, this is AA terminal. And remember that some part of the current, armature current, is going to the field. This is shunt field, and this resistance is connected parallel to the armature. We call it shunt field, and this should be connected to load, and this is the load voltage VL, or terminal voltage we can call also. And this is the, as this one is parallel to this, so across we will get the same voltage VL. Now current IA is the armature current, and part of it is flowing through the shunt field. ISH is equal to shunt field current, and this is IL. IL is equal to load current. So what I can write, IA, you remember this equation, IA is equal to ISH plus IL. Now EG, generated EMF EG, is equal to terminal voltage, that is load voltage, plus the drop inside the armature. There is a resistance RA is there. RA is equal to armature resistance, VL plus IARA plus BCD. What is BCD? Brush contact drop. And IL the load current is equal to PL by VL. And ISH is equal to this current ISH, as this one is parallel to it, so you will get across the same voltage VL by RSH. So for solving the numericals, you have to remember all these things. And BCD is the brush contact drop. Here the two brushes are there, so there is drop is there. So sometimes it is written that BCD is equal to say 0.1 volt. So you will multiply it. Total drop is equal to 2 into 0.1. So total BCD drop is equal to 0.1 into 2. That is 0.2 volt. Now this one is the figure for DC shunt generator, where the field winding is connected parallel to the armature winding. Field winding is connected parallel to armature winding. Now so next we will draw another generator. This is my armature terminal. This is A. This is double A. So this is generator. So and field winding is connected in series with the armature winding, and it is connected to load. This current is IA and generated EMF is EG, and this resistance is RAC, and the current flowing through it is IAC. RAC is the resistance, IAC is the current, and this current is IL. So this figure is DC series generator. Now from figure I can write IA, armature current, is equal to series field current is equal to load current, as this one is in series, and IL is equal to PL by VL. Where PL is the actual load. PL is the load in watt. So EG, generated EMF EG, is equal to this voltage is VL. Terminal load voltage is equal to VL. EG is equal to VL plus IARA. Inside there is a drop, IARA. IARA plus IAC RAC plus BCD. So you have to remember this formula for solving the numericals. So now I will solve one question for you. Question is, determine the terminal voltage of a DC shunt generator having a lap-wound armature with the following nameplate details. See, what is there? Mentioned lap wound. In case of lap wound, number of parallel path is equal to A is equal to P. So given, what is given? Number of pole P is equal to 4 and phi is equal to 0.05 Weber. Total number of conductors Z is equal to 400. RA is equal to 0.5 ohms and speed N is equal to 900 RPM. IA is equal to 40 ampere. The moment you got this data and you know what type of generator it is, just draw this one. So it is mentioned this one is a shunt generator. So some part of the armature current will flow to the shunt field. So this is my IA and this is my ISH and it is connected to load. So what to find out? Terminal voltage VL, that is this one, VL. So what we know that EG is equal to VL plus IARA for shunt generator, VL plus IARA plus BCD. So BCD. And BCD is given? No. So we have to ignore that one. So as it is lap wound, so as the armature is lap wound, so A is equal to number of pole. So first I have to find out the EG. EG is equal to Z phi Pn by 60A and A is equal to P, so this is equal to A is equal to P, so Z phi N by 60. Total number of conductor how much? This is 400. So 400 into phi is equal to 0.05 and N is equal to 900 and number of pole is equal to this is equal to 4 and A is equal to 4, cancel, 4 cancel, so and divided by 60. Do the calculations and it will be 300 volt. Verify the answer. And also what we have? Also we have EG is equal to VL plus IARA as BCD is equal to 0. BCD is not given, so this is 0. So right? So VL is equal to how much? VL is equal to EG minus IA RA. So it will be minus. So we are finding VL. VL is equal to 300 minus 40 into 0.5. So how much? VL is equal to 80 volt. So this is our desired answer. So this way you can solve a problem from DC shunt generator.